Good morning. Our report is on predictive research. My partner is K. April N. Uribe and I am Rose A. Malina. Predictive research is an empirical research concerned with forecasting future events or behavior, the assessment of variables at one point in time so as to predict a phenomenon assessed at a later point in time. It studies or determines frequency with which something occurs or its association with something. The major areas in which predictive or diagnostic design are used include business, marketing, clinical setting, and government agencies. The term predictive research design is not typically used. However, prediction is a goal of the scientific method. Used as a non-experimental design, correlation analysis, regression, and multiple regression analysis are used to determine and measure the relationship between variables, and in effect, enabling the ability to predict the changes in the dependent variable based on the value of the independent variable. For example, a researcher might collect high school data such as grades, extracurricular activities, teacher evaluation, advanced courses taken, and standardized test scores in order to predict such college success measures as grade point average at graduation, awards received, and likelihood of pursuing further education. In the clinical field, predictive research is also called diagnostic research. The statistical tools used include regression, linear regression, and logistic regression. Prediction does not care about the relationships between independent and dependent variables. Its only concern is, given a set of inputs with specific values, predicting the outcome with the highest accuracy possible. In these cases, with a properly computed predictive model, one can state, given these attributes and their values, we can state with 80% true positive accuracy that a person, event, organization, or etc. belongs to class Z. This is widely used in medical diagnosis, with many healthcare organizations moving beyond expert rules-based system to using neural networks that may have been trained on massive data sets to diagnose patients' conditions. In diagnostic research, the researcher must be able to define clearly what he wants to measure and must find adequate method for measuring T along with clear-cut definition of population he wants to study. Here's an example. The study is entitled Deep Learning for Prediction of Obstructive Disease from Fast Myocardial Perfusion SPEC, a multi-center study. The study evaluated the automatic prediction of obstructive disease from myocardial perfusion imaging, or MPI, by deep learning as compared with total perfusion deficit, or TPD. A total of 1,638 patients, 67% of which are men, without known coronary artery disease are the participants in this study. Deep learning was trained using raw and quantitative polar maps and evaluated for prediction of obstructive stenosis in a stratified tenfold cross-validation procedure. The conclusion in this study stated that deep learning has the potential to improve automatic interpretation of myocardial perfusion imaging, or MPI, as compared with current clinical methods. My partner, Kay, will give you some examples or journal articles using a predictive approach later. Nonlinear statistical methods are predominantly predictive, including flexible discriminant analysis, support vector machines, k-nearest neighbors, and neural networks. These are difficult to impossible to interpret because x1 gets a new coefficient depending on its value in a range of values. This research is beneficial not only in the clinical fields, but predominantly in business, for predicting business outcomes or potential of employees. This is not to say that inferential techniques cannot be predictive, because they are all predictive, albeit with lower accuracy. except in cases where there is a purely linear or computationally singular relationship between inputs and outcomes. But in many cases, a predictive technique does not provide inferential information, such as the case with deep learning neural networks. There are pros and cons in using predictive research. One of which, in pro, is accurate modeling of nonlinear relationship, which is almost everything. For con, we have lack of understanding of a distinct change in X causing a specific change in Y. Prediction research and etiological research. Prediction research shares many similarities in the design and conduct with etiological studies. Both may assess the relationship between a set of variables and an outcome of interest. Use the same statistical model to quantify the association for each of the variables, and use the same metrics to describe how well the model fits the data. There are, however, several notable differences. For example, in the world of medicine, prediction research is not aimed at understanding the disease process, but at investigating the use of risk prediction in healthcare for informing individuals and for assisting decision-making. The intended healthcare use has implications for the choice of variables or predictors, outcome, and study population. Also, the assessment includes additional measures that quantify the predictive ability and clinical utility of the model. Clinical or public health relevance and feasibility are evaluation criteria that influence prediction studies, but play a lesser role in etiological studies. Here are a few terminologies. Risk factor is generally used to describe factors that are causally related to getting the disease. Prognostic factor refer to factors that affect prognosis of the disease. And predictive factors refer to factors that relate to treatment outcome. Predictors are the variables in the prediction model, irrespective of whether they are causally related or what outcome they predict. Predictors may be causally related to the outcome, but not necessarily. The first step in developing a predictive model when using traditional regression analysis is selecting relevant candidate predictor variables for possible inclusion in the model. A backward elimination approach starts with all candidate variables, and hypothesis tests are sequentially applied to determine which variables should be removed from the final model. Whereas a full model approach includes all candidate variables to avoid potential overfitting or selection bias. Previously reported significant predictor variables should typically be included in the final model regardless of their statistical significance. Note, however, that the number of variables included is usually limited by the sample size of the dataset. Regression analysis. Regression analysis is a subset of the general linear model. It yields a regression equation as well as an index of the relationship between the dependent and the independent variables. For example, the first-year college grades are the outcome of the following predictors. First, the standardized test scores, the courses taken in high school, letters of recommendation, and the extracurricular activities. Multiple regression. Multiple regression analysis is used in predicting objective variable using multiple explanatory variables. It is also used to find out how much influence the factor or predictive variable has on the outcome or the objective variable. Multiple linear regression analysis produces predictive formula of the form, which is y equals ax1 plus bx2 plus cx3 plus d, where x1 minus x3 are explanatory variables, a to c are regression coefficients, and y is the objective variable. We have here a primer on predictive models. Validation can be performed using internal or external validation. A common approach to internal validation is to split the data set into two portions, a training set and a validation set. If splitting the data set is not possible given the limited available data, measures such as cross-validation can be used for internal validation. Predictive research applies statistical methods and/or data mining techniques without preconceived theoretical constructs to predict future outcomes. Example, predicting the risk of hospitalization readmission. Although predictive models may be used to provide insight into causality of pathophysiology of the outcome, causality is neither a primary aim nor a requirement for variable inclusion. Non-causal predictive factors may be surrogates for other drivers of disease, with tumor markers as predictors of cancer progression or recurrence being the most common example. Validating a predictive model. You have three: apparent validity, internal validation, and external validation. Apparent validity pertains to the performance on sample used to develop model. This is easy to calculate. Results in optimistic performance estimates. The second is the internal validation. Pertains to the performance on population underlying the sample. This is more difficult to calculate. Test model in new data random from underlying population. The third is the external validation. This pertains to the performance on related but slightly different population. This is moderately easy to calculate. Assessing the performance of a predictive model. The overall model performance can be measured using R-squared, which characterizes the degree of variation in risk explained by the model. The adjusted R-squared has been proposed as a better measure, as it accounts for the number of predictors and helps to prevent overfitting.
Hi everyone, my name is Kay April and I will be providing some examples of predictive research model. Several researchers have applied multiple linear regression to predict students' learning performance or to identify at-risk students by predicting the course pass or fail. With the rapid growth of information technology, the number of collected data variables from blended learning environments has also increased considerably. However, the number of used variables considerably affects the goodness of fit of the prediction model obtained using multiple linear regression. For predicting students' learning performance by using multiple linear regression, several researchers have reduced the number of variables through selecting some variables with higher predicting power. Therefore, the aim of the current study was to investigate whether multiple linear regression is suitable for predicting students' academic performance by using multivariable learning profile collected from the proposed blended calculus course. For the datasets of the learning activity and learning variables, the students' learning data collected in the study is comprised of video viewing behavior, exercises, homework completion, and quiz grades. For guiding students to continue learning calculus, the instructor assigned paper format homework exercises to the students every 2 weeks. To measure the learning performance for each learning topic, the instructor administered a quiz in the class every 2 weeks. The proposed blended calculus course lasted 18 weeks. That is, there were 9 homework assignments and forming unstructured data to structured data to simplify the analysis. To obtain the best explanatory power of the regression model, the principal components were extracted from the original data after the pre-processing step in the proposed student academic performance prediction model. In the screen plot shown in Figure 3, each of the bar chart and each point in the line chart represent the explanatory power of each component and the accumulated explanatory power, respectively. The explanatory power of the first component for the regression model was higher than 81%. By contrast, the accumulated explanatory power levels of 6 components were higher than 96%. We now have here a sample journal article featuring a predictive research design. We have a predictive correlation study What human capital and demographic factors relate to credential completion for STEM students by Ricky Dale Jensen. The study used a predictive correlation design using logistic regression. So this dissertation examines the educational attainment of college STEM students in Arkansas in an attempt to identify the human capital factors that predict completion of a STEM degree or certificate. Students seeking STEM credentials were identified using the state higher education database from the state of Arkansas, including the public 4-year universities and 2-year college STEM students from 32 colleges and universities were included from 3 cohorts and tracked 6 academic years. The criterion variable was STEM credential earned, whether or not the student earned any STEM undergraduate credential. More specifically, the purpose of this quantitative predictive correlation study is to examine human capital theory and how it relates to the criterion human capital attribute of college credential attainment to the predictor variables of high school GPA, ACT placement test scores, remedial status, gender, race, ethnicity, and age for the first time entering college students in the state of Arkansas. A number of hypotheses was proposed for the study. It includes whether or not there is a predictive relationship for each predictor factors mentioned earlier, the high school GPA, ACT placement scores, remedial status, gender, race or ethnicity, and age for the first time entering college STEM students. We also have here our null hypothesis for every predictor variable. So, first, the human capital factor of high school GPA has no predictive relationship with college credentials earned in Arkansas for first time entering STEM majors, and so on for the ACT Composite Placement Exam, ACT Mathematics Placement Exam, ACT English Placement Exam, ACT Reading Placement Exam, and for the remedial status. The results indicated that high school GPA was highly predictive with ACT mathematics scores having predictive capability but with limited effect size. Two other variables, the remedial status and gender, were predictive for 2 of 3 cohorts. This makes them the secondary predictors. So gender had a positive relationship with STEM credential earned with odd ratios from 1.404 to over 2, low significant levels at 0.05, and a medium to strong effect size. This is another example of a journal which features a predictive research design, a predictive correlational study of the relationship between grit and self-efficacy beliefs among pre-service teachers. This study investigated the personality trait of grit as a predictor of self-efficacy beliefs of pre-service teachers completing a teacher preparation program in a mid-Atlantic university. Its research question is, can grit score as measured by the short grit scale predict the pre-service teacher's self-efficacy beliefs as measured by the teacher's sense of efficacy scale? The study used a predictive correlational research design to determine if a predictive relationship exists between grit test scores and self-efficacy scores of pre-service teachers. For the purposes of the research study, the grit S scale score was the predictor variable and the teacher's sense of efficacy scale score was the criterion variable. The correlational research design is appropriate for this study due to the use of quantitative variables in the prediction of a relationship. In addition, the person-product moment correlation is the bivariate measure that was computed to determine the strength and the direction of the relationship. In conclusion, the study investigated the relationship between two variables of grit and self-efficacy of pre-service teachers. The results of the study indicated a limited predictive relationship between grit and self-efficacy.